Greenland is currently losing around 260 billion tons of ice to the ocean every year, and that figure is increasing now. Scientists have discovered a new threat to the stability of the ice sheet, a series of temporary lakes that are draining in a chain reaction. This is causing freshwater and heat to be carried to the bottom of the ice sheet, making it unstable. Researchers are worried that a collapse of the ice sheet from this draining chain reaction could happen sooner than expected, driving up sea levels. Scroll down for video. An international team, led by Cambridge University researchers, combined 3D computer modeling and real-world observations to study the lakes, with more lakes appearing on the ice sheets. Little was known about the impact they would have. The research team found that the methods in which the lakes disperse can cause significant damage to the survival of the ice sheet. Study lead author Dr. Paul Christopherson of Cambridge's Scott Polar Research Institute said this growing network of melt lakes, which currently extends more than 100 kilometers (62 miles) inland and reaches elevations as high as 2,000 meters (6,500 feet) above sea level, poses a threat for the long-term stability of the Greenland ice sheet. This ice sheet, which covers 1.7 million square kilometers (656,400 square miles), was relatively stable 25 years ago but now loses 1 billion tons of ice every day. This causes 1 millimeter of global sea level rise per year, a rate which is much faster than what was predicted only a few years ago. Previous research has found that if the Greenland ice sheet was to melt, it would raise sea levels by 24 feet (7.4 meters). This dramatic rise would result in disaster for billions of people, as many coastal communities would become completely submerged below the sea. Dr. Joe Cook, a glacial microbiologist at Sheffield University, is involved in a separate study looking at the melting of the Greenland ice shelf. In an interview with the BBC, Dr. Cook said that although the likelihood of the entire ice shelf melting is thin, it could still end in catastrophe. He said, "It doesn't all have to melt for more people to be in danger, only a small amount has to melt to threaten millions." In coastal communities around the world, the latest research found that cascading events, including one case where 124 lakes drained in just 5 days, can temporarily accelerate ice flow by as much as 400%. This makes the ice sheet less stable and increases the rate of associated sea level rise. Lakes form on the surface of the Greenland ice sheet each summer as the weather warms. Many exist for weeks or months but drain in just a few hours through more than a kilometer (0.6 miles) of ice, transferring huge quantities of water and heat to the base of the ice sheet. The affected areas include sensitive regions of the ice sheet interior where the impact on ice flow is potentially large. It had been previously thought that these drainage events were isolated incidents, but the new research shows that the lakes form a massive network and become increasingly interconnected as the weather warms. When one lake drains, the water quickly spreads under the ice sheet, which responds by flowing faster. The faster flow opens new fractures on the surface, and these fractures encourage the drainage of other lakes. A chain reaction is triggered that can drain many other lakes, some as far as 50 miles (80 kilometers) away. The findings show how forces within the ice sheet can change abruptly from one day to the next, causing solid ice to fracture suddenly. The model developed by the researchers shows that lakes forming in stable areas of the ice sheet drain when fractures open. This can happen in response to a powerful force caused by the other lakes draining away. The Paris Agreement on Climate Change has 4 main goals with regards to reducing emissions. 1. A long-term goal of keeping the increase in global average temperature to well below 2 degrees Celsius above pre-industrial levels. 2. To aim to limit the increase to 1.5 degrees Celsius, since this would significantly reduce risks and the impacts of climate change. 3. Governments agreed on the need for global emissions to peak as soon as possible, recognizing that this will take longer for developing countries. 4. To undertake rapid reductions thereafter in accordance with the best available science source. European Commission Dr. Christopherson said transfer of water and heat from surface to the bed can escalate extremely rapidly due to a chain reaction. In one case we found all but one of 59 observed lakes drained in a single cascading event. Most of the melt lakes drain in this dynamic way, although the delivery of small amounts of meltwater to the base of the ice sheet only increases the ice sheet's flow locally. The study shows that the response of the ice sheet can intensify through knock-on effects when a single lake drains. The researchers explained that ice flow temporarily accelerates along the path taken by water flowing along the bottom of the ice sheet. Dr. Christopherson said transfer of water and heat from surface to the bed can escalate extremely rapidly due to a chain reaction. In one case we found all but one of 59 observed lakes drained in a single cascading event. Most of the melt lakes drain in this dynamic way, although the delivery of small amounts of meltwater to the base of the ice sheet only increases the ice sheet's flow locally. The study shows that the response of the ice sheet can intensify through knock-on effects, study co-author Dr. Marion Bougamont, also from the Scott Polar Research Institute, said the transformation of forces within the ice sheet when lakes drained is sudden and dramatic. Lakes that drain in one area produce fractures that cause more lakes to drain somewhere elsewhere. It all adds up when you look at the pathways of water underneath the ice. The researchers used high-resolution satellite images to confirm that fractures on the surface of the ice sheet open up when cascading lake drainage occurs. Dr. Christopherson added, "This aspect of our work is quite worrying. We found clear evidence of these crevasses at 1,800 meters, 5,900 feet above sea level and as far 135 kilometers, 83 miles inland from the ice margin. This is much farther inland than previously considered possible, while complete loss of all ice in Greenland remains extremely unlikely this century." The research team concluded that the highly dynamic manner in which the ice sheet responds to Earth's changing climate clearly underscores the urgent need for a global agreement that will reduce the emission of greenhouse gases. The Paris Agreement is an international agreement to limit greenhouse gases and global temperature rise to 2 degrees Celsius. It also states that it hopes to limit the increase to 1.5 degrees Celsius, as this would significantly reduce risks and the impacts of climate change as long ago as 1973. A study suggested that an ice-free Arctic Ocean could make regions further south colder. That warm Arctic cold continent WAC pattern is sometimes dubbed WAC-Y or wacky among climate scientists when unusually warm air enters the region. It melts ice covering the waters of the Arctic Ocean. This ice normally serves as an insulator, stopping the flow of thermal energy from the water's surface into the atmosphere. Without the ice in place, the oceans can transfer a huge amount of this energy into the air above. This in turn increases air temperatures and this warm air rises up into the upper atmosphere, where it reaches the jet stream. Jet streams are fast-flowing, narrow currents of air that carry warm and cold air across the planet. Much like the currents of a river, they cover thousands of miles as they meander near the tropopause layer of our atmosphere. The strongest jet streams are the polar jets, found 30,000 to 39,000 feet, 5.7 to 7.4 miles / 9 to 12 kilometers above sea level at the North and South Pole. In the case of the Arctic polar jet, this fast-moving band of air sits between the cold Arctic air to the north and the warm tropical air to the south. When uneven masses of hot and cold meet, the resulting pressure difference causes winds to form. During winter, the jet stream tends to be at its strongest because of the marked temperature contrast between the warm and cold air. The bigger the temperature difference between the Arctic and tropical air mass, the stronger the winds of the jet stream become. The Arctic polar jet, which can reach speeds of up to 200 miles per hour, 320 kph, flows over the middle to northern latitudes of North America, Europe, and Asia and their intervening oceans. It moves from east to west, although its exact route varies and can be affected by various factors. With the ice melt in the Arctic and the introduction of warmer air, the route of the jet stream becomes wavier and more erratic. That means that the colder air it carries from the Arctic can penetrate further south and warmer air from the tropics is carried further north. If the jet stream's meander buckles south of the UK, it attracts cold air from the Arctic. Conversely, when it swings north, it sucks warm air from the tropics.
Tell me where the freak's at.